Hello, for the next part, 2.3, we are going to talk about comparing fractions with each other. Alright, so for this one, which is more, 3 out of 7 or 5 out of 7? In this, we are going to compare a whole that's split up into 7 parts. So that'll be 1, 2, 3, 4, 5, 6, I'll add another part there, 7. And when we're comparing, the whole has to be the same size between these two fractions. So notice I drew 2 bars that are the same size and divided them both into 7 parts. Now the first one is 3 out of 7, and the second one is 5 out of 7. So when we compare them, we're able to see that 5 out of 7 covers more of the fraction bar, making that number the largest. Now, if we follow that same logic, we have 9 out of 10 and 7 out of 10. Because they are both split into 10 parts and our whole would be the same size, whichever one has more parts shaded would be the larger fraction. So 9 is more than 7, which would make 9 out of 10 more than 7 out of 10. Then for example 3, we want to make sure we are reading the problem. This one is asking which is less. Looking at this, they are both split up into 6 parts, and we have 5 out of 6 or 4 out of 6. Because they're split into the same number of parts, whichever one has the least amount of parts shaded would be the less amount. So in this one, 4 out of 6 is less than 5 out of 6. Then example 4, compare which is less. Again, these are both split into the same number of parts. So whichever one has the smaller value on top or the fewer number of parts shaded is going to be our smaller number. So in this one, 8 out of 13 is less. All right, this is something, since you're watching a video, you probably don't have someone next to you to talk about, but think about this for a moment. If you had to choose what fraction of a candy bar you got, would you rather have 5 out of 6 or 5 out of 7 of the candy bar? Explain your reasoning. So now that you've had a moment to think about that, I'm going to go over my reasoning. For this, I would rather have 5 out of 6, because if we have 2 candy bars that are the same size, if I split one into 6 pieces and then one into 7 pieces, 4, 5, 6, 7. And then if I took 5 parts of each of these, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Oops, I think I made this one into too many parts. 1, 2, 3, 4, 5, 6, 7. I sure did. Sorry about that. Nope, I did it again. There we go. Okay, so the top one is split into 6 pieces and the bottom one is split into 7. And if I shade 5 in both of them, I notice that the parts where it's only split into 6 pieces, the parts are bigger. And the one that's split into 7 parts, the parts are smaller. Oops. So that means the 5 out of 6 is larger or more of the candy bar than 5 out of 7. So when two numbers have the same numerator or number on top and different denominators, you can tell by which one is larger by which one is split into less pieces. Because the less number of parts that you have to split it between, the bigger the parts are going to be. All right. So then let's compare these two. 3/4 or 3/5. So right away, I notice both of these are talking about 3 parts. So I want to figure out which one has the bigger parts. So this one is only split into 4 pieces, and this one over here is split into 5. So that means these are going to have bigger parts. And the one split into 5 is going to have smaller parts. So whichever one has the bigger parts, or it's split into the fewer number of pieces, that is going to be the larger or the greater number. Now let's go to our next example. Compare 18 over 19 and 18 over 17. Again, these are both the same number on top. And when it's split into a smaller number of parts, that means the parts are bigger. And the higher the denominator is, it means the smaller the parts. So that tells us 18 over 17 is going to be the greater number. Another way that we could determine which one was greater, if we look, 18 is larger than 17. So that means this number is more than 1, or more than a whole. And 18 over 19, that's less than a whole. So the one that's more than one whole is obviously going to be the greater number. So this one, there's two different ways to logically think through that problem. All right, our next one, 11 over 20 and 11 over 19. Which is greater? And again, that's going to be 11 over 19 because it's split into less pieces. So that means the parts are going to be bigger. Okay, another example, 7 over 50 or 7 over 51. So the one split into 50 parts, those parts are going to be bigger, making that one larger. So that means 7 over 51 is going to be the less, because this one's asking for which one is less. Let's go back and check the last one. Yep. So one thing that I almost forgot to do is make sure you read the directions. All right, and our next slide, once it loads, compare which is less. So again, less on this one. They're both talking about 10 parts. So the one that's split into more pieces, these ones are going to have smaller parts. And the less pieces it's split into, that's going to have larger parts. And then this one, that means the one with the smaller parts is going to be the less of the two. All right, observation. When comparing fractions with the same numerator, so number on top, the larger denominator has smaller parts. So the larger denominator would be the smaller value because it has less space that it's taking up. That also means the smaller denominator has larger parts because we're splitting it up into fewer pieces. So because the smaller denominator has larger parts, that would make that the larger number. All right. Now, what do we do when the fractions do not have a common denominator? So for these, which fraction is greater, 1 over 8 or 5 over 7? You might be able to logically think through this as 1 over 8, that's really close to 0. And 5 over 7, that's closer to 1 than it is. So that would make 5 over 7 greater. One way that you can check your answer is by getting a common denominator. So this first fraction, 1 over 8, I'm going to multiply both the top and the bottom by the denominator of our second fraction. So I'm going to multiply both of these by 7. And that would make this fraction 7 over 56. Then the second fraction, I'm going to multiply by the denominator of our first fraction. So I'm going to multiply both of these by 8. And that would give us the fraction of 40 over 56. Now that they have both the same denominator, so both parts are going to be the same, it's easy to compare because whichever one is greater is going to have more parts shaded in. So 5 over 7 would be our answer because it is the bigger part. So sometimes you can tell without getting a common denominator, but to check your work, this is a great way to do it, to get that common denominator on the bottom. All right, our next one. We have 3 over 7 or 5 over 8. Again, I know half of 7 is about 3.5, so I know this is less than half. And 5 over 8, half of 8 is 4, so 4 over 8 would be equal to 1/2. So I know this is more than a half. So because of that, the number that is greater is going to be 5 over 8. And again, the way that we can check is by multiplying by the denominator of the other fraction on the top and the bottom. So 3 over 7, when we multiply those both by 8, we would get 24 over 56. And then 5 over 8, we'll multiply both of those by 7. And that gives us 35 over 56. And that shows that, again, 5 over 8 is more, or the greater number, because it's more than 24 over 56. All right, our next one. Which fraction is greater? 2 over 5 or 4 over 6? Again, 2 over 5, that's going to be less than 1/2, because half of 5 is 2.5. So 2 parts out of 5 is less than 1/2. Half of 6, that would be 3 over 6 would be 1/2. So I know 4 over 6 is going to be more than 1/2, making the greater fraction 4 over 6 again. And one way, again, we can check our work is by multiplying by the denominator of our other fraction. So 2 over 5, I'm going to multiply both of those by 6 to get 12 over 30. And then 4 over 6, I'm going to multiply those both by 5. And that will give me 20 over 30, showing again that that number is greater. All right, our next one. Which fraction is greater? So I want you to go ahead and try this one on your own. Okay, for mine, I know this one is less than 1/2 because 5 over 10 would be 1/2. This one I know is more than 1/2 because 6 out of 12 would be 1/2. And one way that I'm going to check my answer is multiply both of these numbers by 12. That gives us 48 over 120. And I'm going to multiply both of these by 10. And that gives us 70 over 120. Showing that this number is, again, greater than the other. All right. If you need another example, you can go ahead and do these next ones and then check your answer. One thing that you want to do when comparing fractions, numbers that you can compare them to is figuring out which is closer to 0. If it is more or less than 1/2. Or you can get a common denominator. So those are all things you can do when you are comparing fractions. So if you feel like you are ready to do the IXL practice, you can go ahead and do F6, compare and order fractions. Make sure you read the directions. Sometimes it'll be greater, sometimes it'll be less. So make sure you do that. It'll help you get through them. If you need a few more examples, I'm going to go through the rest for the remainder of the video. All right. So if you needed more examples, number 14. they want you to compare 5 over 6 or 6 out of 7. Looking at these, I noticed that both the numbers on top are one less than the number on the bottom. And we talked about the larger the number, the smaller the parts. And the smaller the denominator, the larger the parts. So when we compare 6th and 7ths together, the 7th parts are going to be a little bit smaller and the 6th parts are going to be a little bit bigger. Both of these need one more to become a whole. And I know that the parts in the 7th are going to be smaller. So that means 6 out of 7 is closer to the whole than 5 out of 6. And one way we can check that, again, is by getting that common denominator. So I'm going to multiply both of these by 7. That gives us 35 out of 42. And then the second fraction, I'm going to multiply both of these by 6. That'll give you 36 out of 42. And we'll notice that, again, this number, the 6 over 7, or 36 over 42, is closer to the whole. So that is another way that you can check which fraction is greater. All right, our next one, 7 over 8 and 8 over 9. Again, both of the numbers on top are one less than the denominator. So I'm going to think this one's split into 9 parts, so this one's going to have smaller parts. And this one's split into 8, so this one's going to have larger parts. So the one that only needs one more small part, that's going to be the largest number. And again, we're going to check our answers by getting that common denominator. And this one will give us 63 over 72. And then 64 over 72. Showing again that that 64 over 72 is the larger number. So 8 over 9 would be our answer. All right, and then our last example, which fraction is greater? 4 over 5 and 9 over 10. Again, these are both one away from becoming a whole. And the ones split into 10 parts, those ones are going to be the smaller parts. So if I need one more small part compared to this one, where I need one more large part, the one that needs one more small piece is going to be the larger number. And we can go ahead and check. So getting that common denominator, that'll give us 40 over 50. And these ones we have to multiply by 5. That'll give us 45 out of 50. So again, this one is closer to that whole, or all of our parts, to make one. And that shows that 9 over 10 is larger than, or more than, 4 out of 5. All right. So again, if you are at this point, you should be good to go on the next IXL. So if you watched the last few examples, hopefully you are more prepared for these. And if you have questions,